for Git for IBMI. I'm Maya and I work in marketing here at Eradani. We only have 45 minutes for this session, so I'm gonna just do some quick housekeeping and then we'll jump right into it. I am recording today's session. You will all receive an email with the recording tomorrow. Feel free to pass that along to anyone you would like. And if you have any questions, they can reach out to me at any time through email. It's just my first name, maya@eradani.com. Secondly, if you have any questions during the session, you can put them in that little question and answer box at the bottom on your Zoom toolbar. It's going to be right below there, and we will get to them if we can. If we run out of time, we will definitely follow up with you through email. And I am here today with Dan, our CEO, and Aaron, our Chief Architect. We're really excited to show you some awesome stuff today. And with that, I am going to pass it over to Dan.
Great. Thanks, Maya. We are ready to get started. Okay, so today we're going to be talking about Git for IBMI. So we're going to talk about both about Git itself and we're going to talk about IBMI, but we're also going to talk about the broader DevOps, the entire DevOps tool chain. So we're not going to just talk about Git because Git is really just for source control. We're going to talk about Git for source control. We're going to talk about how do you do IBMI builds because Git doesn't actually know how to do that. And how do you do deployments of IBMI codes. We're going to talk about the entire DevOps lifecycle. So that's why it's enterprise DevOps without the enterprise pane. We're going to be able to show you how you work with IBMI code. But at the center of all that is Git. So we're going to start out with an introduction to, what is Git? Why would you want to do this? What is Git going to bring to the table for you? Because it does represent a change from probably how you've been doing things. So we'll take a look at that. And one of the very powerful functions of Git is its ability to handle parallel development. That is having multiple people working on the same things at the same time. The idea being is you don't have to wait for somebody else to finish their work before you can start your work because Git will protect you from accidentally overlaying one set of changes with another, and it will give you very powerful tools for merging the code when you're ready to run. So you can work on the things that are at highest priority for you, and when you're ready, Git will help you with how do I merge the changes together. And then we'll talk a little bit about what Eradani is doing to help make that possible, to help Git work with IBMI code. And throughout this, I'm actually going to be showing you demos. I'm going to show you exactly what this looks like in real life. And as Maya said, if you have questions, please post them in the question area of the meeting. Aaron is going to be monitoring that while I'm talking. When he's talking, I'll monitor it so that you can see, so that you can get answers to your questions. And if we can, we'll answer it as we go. So let's take a look at a little bit about Git and why you want to adopt Git. Well, and one of the big reasons is that it is the de facto version control tool for development in the world today. It is what everybody's using. I don't think I've ever seen any product in any area that has quite the market dominance that Git has. If you look at it, this is the percentage of developers that are using Git. And you can see it's flattening out just because simply there just isn't that many more people to get. So we're already at almost 95% of developers are using Git as their version control tool. And this is coming from a bunch of different studies that all come up with the same result. This is market share. You can see that Git shows here 86.25%, and then Azure DevOps at 9.7%. The issue here is that Azure DevOps actually is Git. So you have to add these together and you get back to that 95% number as far as Git as market share. So in fact, according to this, 96%. But again, the numbers are coming from Stack Overflow, from the GitHub Octaverse report, and from Fortune magazine. We're seeing the same kinds of results. That it's what's going on out there, and why that's important is that probably in your organization, the people outside the IBMI world are already using Git. That's probably going to be the standard that's being used for managing source. And you can just see it in absolute numbers, the kind of growth we're seeing. And this is just GitHub. GitHub is just one of the platforms. There's GitLab, there's Bitbucket, there's lots and lots of Git platforms, and there's just internal Git hosted repositories. And just at GitHub, they're up to 180 million developers. So 180 million developers who are using Git. So it's significant market share. And my favorite chart was this one. it's GitHub visitors by age group. So I like to see that, you see that it's heavily weighted towards the young people, and it gets down here at, 55 to 64-year-olds at 4.3%. Of the visitors who are coming out to GitHub. And I was a little offended by that because it's missing my group, so I added another column here for me. So so for the people who are over 64. But anyway, so this is a little bit of the GitHub demographics. So, upshot of all of that is Git is the de facto standard for doing version control. And it's important to remember that that's what it is. It's version control. It's managing versions of source, and it's really good at doing that. It doesn't do IBM I builds. It doesn't know about IBM create commands. It doesn't know about dependencies in the IBM I world. It doesn't know about deployments. It doesn't do any of that, but it does a really great job of managing source. And what we're going to talk about in this webinar is both about Git and what it can do for you, but also about how do you get all those other things done as well, all those other things that are very, very important parts of your development lifecycle, of the DevOps lifecycle. So let's talk a little bit in more depth about one of the most important things that Git gives you, and that is this idea of parallel development, where you can manage multiple streams of development simultaneously. In a lot of IBM I shops today, I see people using sort of a checkout, check-in model where if somebody has something checked out, nobody else can use it, that it's locked to them. Or if they do allow for it, the process then later on of figuring out, well, who changed what and merging that stuff together can be a pretty manual, difficult process. In Git, it's really built into its architecture is to manage that situation. And the reason being, you have to think about the history of Git. Git was created originally to manage the development of the Linux operating system. And so you literally had thousands of developers all around the world who were working on that project, and nobody had any idea what anybody else was doing. They did keep a, centralized list of what the functions were that they wanted and, what the bug fixes were and all that kind of thing. But everybody was just saying, well, I'll take that one and I'll start working on it. And they worked on their own machine. And then they would push it up to the central repository where it would get reviewed and then merged into the code base. So you had lots and lots of parallel development going on. And that's how they were able to develop this code very, very quickly with these very, very large distributed teams. The idea is I can say, well, I can work on task 1 and task 2 simultaneously, even though they may share some objects. And when I'm ready, I can merge the code together. And you do that using Git's branching capabilities. And we'll talk a little bit about branching.
And Dan, actually, if I can just jump in,
Sure, please.
one thing that we're seeing these days, it's very recent, is this is actually also becoming very important for AI-assisted development. One of the things that we're seeing is the reason why this was so powerful for the development of the Linux operating system is effectively you had a massive distributed team of lots and lots of different people, and you needed to be able to review what each one was doing and see exactly what the changes are and keep them isolated and then bring them in an effective way. Well, when you let an AI loose on your code base, it's going to act in a very similar way. It's going to make big sweeping changes. You don't necessarily know exactly what it's doing. But when it's done, it's going to say, yep, I finished your feature. And you need to then go in and make sure there are no hallucinations in there, right? It's actually achieved the spec that you wanted, and it didn't do any little side effects that are going to be a problem in your application. One of the very, very powerful things that we do with Git in our processes with our programmers is whenever an AI proposes changes to any of our code, we then review using Git exactly what changes it made to every single object. We keep them isolated in a separate area in Git until we're actually ready to pull that in. So, with the speed of development, it's kind of like every developer is a distributed team in themselves because they all have these coding agents now. And so they're all using this to manage that development. And that's making it possible for them to move a lot faster.
Great. Thanks, Aaron. Yeah, so in fact, let me before we go on with the PowerPoint, just because Aaron brought up some of that ability to see what's going on, let me bring up here a view of a Git repository. So here we're looking at a Git repository in GitLab. Now this could be a Git repository in GitHub, it could be in Bitbucket. There again a variety of hosting environments for Git, or you could have your Git repository just sitting on your IBM I. You can have the Git repository wherever you want. That's the kind of cool thing about Git is it's designed to be a distributed repository where the code can live just about anywhere. But if you see here, I've got a lot of stuff that looks kind of like, IBM I source files, which is exactly what these are, but they're just showing up here in Git. And I'm looking at a view of my repository from the task one point of view. That is, I'm working on task one, and I could be working on, on task two. I could be working in the integration test environment, QA environment. I can have these different stages of my life cycle. But what's cool here is I can go in and say, okay, you know what? I'd like to see what have we been doing for task one. And I can hit this history button. It's going to show me all the changes that we've made for task one. So I can see what they are. Here's a little information about them. What are the changes that you're making? And I can say, oh, well, gee, for that update for the HR enhancement, or this fixed a bug in my enhancement code, or adding the enhancement, what did I do? What did I actually change? So I can go in here and say, show me what I changed. And so I can see information about it, and I can see here, well, you changed this physical file, and this is what you changed. You changed this physical file, this RPG program, and I can actually see the changes that I've made for that particular task, that particular thing that I was working on. So a lot of information about the history. Beyond that, I could go in and say, I can say, okay, you know what, I'm really interested. I'm having a problem with a particular program. Maybe I'm having problems with this CUA PGM1 program. I'm going to go in here and say, okay, let me go look at that. And I'm going to hit the blame button here. And what it does is it shows me now for every line of code that's changed, it's showing me who changed that code, why they changed it. So if you think about this, a lot of us use the change dates in the source lines to try to figure out what was changed. Gee, things that were changed and have the same change date, they must have been changed for the same reason. Here in Git, I don't have to worry about that. I can actually see for every line of code that was changed, why it was changed. I can see who changed it, when they changed it, why they changed it. And what's really cool is that I can roll backwards in time. I can say, okay, so the last change to this line was, adding new function requested by end user. That was the project I was working on. But I can say, well, what was the change I made before that? And now it says, okay, well, you made changes for dispatch. And then I say, okay, well, what was the change I made before that? So I can go back and I can just keep rolling backwards in time, and I can see every change because Git is tracking every single thing that you do. So it knows who did it, when they did it, why they did it. So again, as Aaron was saying, if you've got code that's being generated by an AI, you can see here's what it changed. These are all the changes that it made. And we'll see in a minute when I walk you through the sort of the development life cycle that you can have people who have to review that code. So you can require that somebody look at that code before it actually moves forward. So you have lots and lots of options about how to work in this environment. So that's kind of just a quick view into what Git can do for you if you're using it. And again, I'm going to show you in a minute. We'll actually walk through an actual change or set of changes using Git for your IBM I code. So let me go back over here to the PowerPoint. So we talked about, you can do that branching. So like we saw in that the GitLab view, I had the task one branch, I had the task two branch, I had the QA environment, I had the integration environment, I had production. So each of those are a Git branch that you can look at and say, okay, well, just show me what's in production, what's in QA, what's in integration test, what's in task one. I can see exactly what the status is of each of those stages of my life cycle. So parallel development, that ability to do that branching allows you to have multiple developers working on multiple projects simultaneously. Those streams can then be merged together later on, so you don't have people waiting for somebody else to finish something before they get started. So you can increase your velocity through this kind of continuous integration environment. And there have been now a whole series of studies on this ability to do parallel development and how does that impact teams. So you can see these are just some of the studies that have been a 20% productivity increase, less errors, enhanced collaboration among the developers, so people can see what each person is doing, and they can work with the changes and merge them together. And these are the functions within Git that allow you to do that. One of the cool things about a branch is it's a very lightweight thing. You can create a branch at any moment in time. You can say, oh, gee, I need to, somebody just called me and said there's a production problem. I need to do a quick fix. I'm going to create, if I'm allowed to, if I'm authorized to, I'm going to create an emergency branch right off of production so that I can go in and make this change, and I'll push that change into production. I now have a record that change was made as an emergency fix. And all of the other environments that might have copies of that code will know that they can't just simply overlay it, that they're going to have to do a merge of that code into their code base. So when they try to move things forward, Git will let them know that, oh, there was an emergency fix. You need to figure out, do you want that code, not want that code? What do you want to do with it? And a lot of that merging can be done automatically. Git has very powerful algorithms for figuring out how do I put code that was changed in parallel, how do I put that stuff together? And again, you have that complete history of everything that's changed. So basically, a typical workflow might be, I get assigned a task, I create a branch for that task. So I now have a branch that represents that task. I start doing my development associated with that branch, and that way, at any moment in time, people can see exactly what it is I've done. They can see the changes that I'm making. Other people can be working on other tasks, and they don't have to worry about what I'm doing. They just do they do their thing, and eventually we can merge them together. Now, if you are concerned about, gee, well, I don't want you to go too far down the road of working on that branch before we start putting our code together, at any time you can say, you know what, go get the stuff from that task branch and merge it into mine. I want their code. I want to make sure I've got their code. So at any time you can choose to do that, but you don't have to. You can have those things working in parallel and then simply merge them when you're done, which would actually be a much more typical way of working, is to just everybody does what they need to do, and then you merge things together. It does also mean, though, that you typically want to merge early and often. So you don't want to have months and months and months of work building up before you actually take a look at doing that merge. You want to try to do those merges as often as possible. It's why they refer to this as a continuous integration environment, where you're constantly integrating the changes back together. But again, it's up to you. You get to completely control when that happens. And these are the things that have come up as the benefits of being able to do this, and it really comes down to much faster time to market for getting the code out more quickly. So that's basically the sort of the Git parallel development thing. It is the modern way of doing things. But there are challenges for IBM I users for using Git. First of all, Git does not understand libraries and source files and source members. It has to have things in directories. So you have to have a way of managing that relationship between the directories and then the source files and libraries, where you might be keeping code. You might, if you're still doing creates, which almost all IBM I users are, from the library source files and source members, you need to make sure that that's being kept up to date with what the Git repository says is the source of truth, is where things should be. So you need to make sure that those things are staying in sync. Now, Git doesn't do builds, so you need some way to say, okay, I'm now ready to test the changes I've made. Go ahead and create the things I changed, and by the way, create all the things that use the things I've changed. And Git does not understand, IBM I create commands. It doesn't understand create options. It doesn't understand dependency relationships, because the whole build process is really outside of what it's designed to do. Its mission in life is source code and managing source code, not the whole build process. And then IBM I users, again, tend to use the checkout check-in process or check out and promote process, whereas Git uses a process that is a Git add, a Git commit, and a Git push. And I'm going to show you what those processes look like. And then IBMI tools typically rely on a structured, rigid sort of promotion to production process. Code goes from my development environment to a test environment to production, or development to test, to QA to production, whatever that process is. Whereas Git offers a lot of flexibility, and that's a double-edged sword. It's having a very fixed, rigid process makes things very, very easy, but it limits what you can do. Git's ability to create branches and all kinds of different paths to production can introduce a lot of flexibility, but also management issues, things that are hard to manage. And so you can, if you want to, using Git functions, you can lock that down and say, well, no, code only goes from development to test to QA to production. So you can actually mimic that kind of a process if you want to. In Git, it's just a matter of setting up your branching rules to enforce that, which you can do. So
Dan, hold on, let me hold you for 1 second, because we got a question that I think is very relevant to what you were just talking about.
Sure.
Question says, that's all well and good, but does this mean that if I want to work with Git, all of my developers have to work with it? Is it impossible to have a mixed setup where some developers are working in SEU on the IBMI while others are working against the Git repo in Azure?
So great question. I think it's a setup for this particular screen.
That's what I wanted to bring up.
It's a really great question, and it's kind of the kind of why Eradani exists, and that is our objective is to make it so that IBMI users can use Git in a way that makes sense for IBMI users. So we want you to be able to say, now I use PDM and SEU, and I want to be able to work in my libraries and source files and source members and do things the way I've always done them. And other people are going to be working in VS Code, and other people are working in RDI. And yet I want to be able to manage all that stuff together. And that's really what Eradani is adding to the mix. Is we've set it up so that you can work in the libraries and source files and source members, and I'm actually going to show you this. And you can use SEU, and you can use whatever IBMI tools you want to use, and yet still have things kept in sync with the Git repository, still have things work with the Git repository. So you can work in both ways simultaneously. So you can work in sort of the traditional IBMI way, or you take advantage of things like VS Code and RDI and use sort of some of the more modern tools and still take advantage of all the benefits of Git. Now, when we go to do the build, again, if you go out to go do a build, there's no way to do that with native Git. Git doesn't know how to do that. So Eradani has a module called iBuild that goes out and figures out all of your objects, where their source code is, how they're related to other objects, so all the dependency relationships, modules to programs, or views to tables, or programs to tables, whatever the things you have set up. It goes out and it builds that database of all those dependencies. So it knows if you've changed some things and you say, go do a create, it will create the things you've changed plus the things that use the things you've changed. So you don't have to worry about getting level checks in production because you changed the file but didn't change the things that use it. And then I deploy the third part of the Eradani set of modules for this environment is something that will then take objects and deploy them out. So again, Git doesn't do distributions of objects. Eradani iDeploy will take a set of things you've just built and say, okay, now I need to give each of my testers their own copy of the database changes, and it can go and do that. Or I need to move the code from my development box to my production machine. So go ahead and just deploy it over there. So iDeploy will do that. So you have iGit that allows you to work with Git, but work with it from standard IBMI environments or from the more modern IDEs. You have iBuild that will do the build process, and then iDeploy that will deploy the code for you. So our idea is that you should be able to work in the way you want to. And to support that, you can see we've got this, let me get this. I'm going to actually, instead of showing you here, let's go ahead and show you live here. So I go in here to my, I'm going to do a work obj Git asterisk here on my IBMI, and you can see we give you a lot of commands. So we've wrapped Git functions in with IBMI commands that you can execute against the IBMI program. So if you make a change to a source and you want to create it, or you want to do a Git add or a Git commit, you can do it right from the green screen. We have these commands, or we actually have PDM options, so you can put a GA next to a program you change, and that will do the Git add function. And same thing with if you wanted to work through say you wanted to work through RDI, right? Same thing here. If I made a change to something here in RDI, I have the ability to go in and make my changes here and access the Git functions directly from here. Or if I wanted to, I could work in Visual Studio Code. And if I came in here, let's open up RPG. I can make my changes in here, and I can say, okay, go out and do my Git add, do my Git commit, do my Git push. I can do all those things directly from here. So it's completely up to you where you want to work and how you want to work. You can work in any of those environments and make your changes. So let's go ahead let's go ahead and get into it. So let's go and say we want to make a change. So we'll go in and say it's I've got some things I want to do. So again, if I go back here to my repository, I've got this task 1, and I want to start making some changes for task 1. I want to go in and do some things that's been assigned to me. I can go in and make my changes. So let's go in. So we can start out. Let's start out here. I'm going to do a work member PDM. And say, okay, I want to make a change to this RPG program. And we'll say it's a change I'm making for the webinar on 1/29/2026. And I'll make the same change here. All right, so I've made my changes in PDM. Go ahead and save those changes. And so I've made the change here in PDM, but somebody else, let's say, or even me, maybe sometimes I use PDM, sometimes I use Visual Studio Code. I'm going to come over here into code and say, okay, I want to make a change to this physical file in Visual Studio Code. So we'll just change this to 29 also. And we'll go ahead and save that change. And then we'll go ahead down here to this physical file. And we'll change this one as well. Right, so I've made some changes now to a couple of physical files to an RPG program. In Git, the next thing you would do is what's called a Git add, where I say, okay, I want to add this thing. So I can right click here, go down here and say, okay, do a Git add. Now I could have done this against a particular file and said, I just want to add this one program. Or I can say, no, go out and find everything I've changed and add them all, which is what I just told it to do. And if I go in here now and do my Git status, if I'm doing my work and I want to just see, well, where am I right now? It tells me you've got these 3 modified things, the physical file, the 2 physical files in the RPG. So even though I made the RPG change over there in PDM in my libraries, Git knows about it. It's there and it's updated. It tells me that, okay, those are the things you've changed. So I've now added those things to my list of changes. So in Git, that's typically how you work. You make changes, and then when you're ready, you say, okay, I want to add this. Now, the reason you have this add step is add in Git is basically a staging process. It says, okay, I'm happy with the changes I've made to these 4 things. Maybe I'm going to go change a bunch of other things, but these 4 things, those I'm happy with. I want to stage them for what's called a commit. A commit in Git is a very important thing. A commit it's a set of changes you've made that put you into some known state that you're happy with. You say, okay, I want to commit these because I've finished, bug fix 1, 2, 3, or I've finished this little piece of the enhancement, and I want to be able to identify what are the things I changed in order to implement that particular thing. So what I could do now is do a commit, but maybe before I do that commit, I actually want to build the code. I actually want to go out there and say, I want to go out and say, you know what? I actually want to do a create of the things I've changed and all the dependencies. So if I go over real quick over here, back to my green screen, and I'm going to do a work lib of CUDEV customer dev one OBJ. So in my environment, the way I set things up is I have a source library for development and I have an object library for development. But you can have everything in one library. You can have different libraries. Other developers can do things differently. That's completely up to you. But I've got it with a source library and an object library. So I can go in here and see, let's go see what's in my object library. And right now it says, yeah, there's nothing in there. The library is empty. So what I'm going to do is I'm going to go back over here to my Visual Studio Code environment and say, you know what? I want to do a create. I want to go out and create this stuff. So I can say, okay, run the Eradani iBuild. And what that's going to do again is it's going to go out and figure out, okay, so what's changed? What are the create options for those things? What create commands should I use? And then it's going to say, okay, and what else do I need to build in order to do this? And it's also going to set your library list so it knows for development, I've got development, and then maybe a test library, and then production in my library list. It knows how to set your library list for this build. So it's now running that. It's actually running that build process for me, and it actually will tell me right here in VS Code or in RDI. If I was using RDI, it shows me here's what was built. So you can see a lot of things were built because I changed the physical files, and basically everything is dependent on those. So it's showing me here's what was built. The only thing it didn't build was a command because it says the command doesn't need to be rebuilt based on this. So if I go back over here to my library and I refresh the library, I now see I've got all that stuff in the library. So I can go in and do those creates. Now, in a minute, we're going to see that you can just automate this whole process to say, when I move to test or when I move to production, just automatically build stuff for me, and it will do that. But so we'll take a look at that in just a second. But anyway, so I went in, made some, I made the changes. I did the add. I can now do my git commit. And again, I could do it in wherever I want to. I could do my git commit from the green screen here. Actually, let's go ahead and I'm going to do a call QCEMD and say, okay, you know what? I'm a green screen kind of person. What's my status? And it tells me, okay, here's where you are. You're working on task 1. Here are the things that you've changed that have currently been changed. And I can say, yep, I'm good with that. Let's go ahead and do a git commit. So that says, I want to be able to identify this package of things. And I'm going to say enhancement from webinar request, or whatever. So I can put in whatever I'd like to do here. So now if I do my git status, to say where am I as a developer, I can see, oh, I no longer am showing that I've got unstaged modified programs. I have a commit out there. So I have a commit, and it's saying your commit is ahead of the origin. So it's ahead of the shared repository. So upstream from me, there's a place where we're putting all these changes. As all the different people working on task 1 make their changes, they can put them into a shared environment. So right now it's saying you're ahead by 1 commit. Now I could go back in and say, you know what, I did that testing that I was doing before, and I found, oh, there was a problem in one of the programs. Something I changed in program 1 here affected program 2, so I need to go in and make a change to program 2. So I'll bring that up and say, okay, yep, we're going to do the same change here. So now I've made my change here. And now I have the same, I'm in the same place now. I've got this change out there, but it has yet to be staged for Git. So I can go in and say, okay, do a Git add. Okay. And then I can do my Git commit. So I'm going to do a Git commit again for this change. So I'm going to get a second commit. And this one I'm going to say fixed bug for webinar change, right? So I can separate those two things. So now I've done that, and if I do my Git status again, it's going to show me that I'm ahead now of the origin by 2 commits, right? So I'm 2 commits ahead, have those 2 things to do. And let's say that now I say, okay, you know what? I'm good. I'm happy with those changes. I want to share these because up till now, if I go and look at my shared repository here in GitLab, let's go ahead and refresh the screen. We're going to see that those changes are not here yet, right? I don't see those webinar changes here yet. They're not in the repository. So what I'm going to do is I'm going to go say, okay, let's do the next thing we need to do, which is a Git push. So I need to do the Git push to push things forward. Now, here's an interesting thing that's specifically for people working in the IBM I world, and that is in the Git world, typically everybody is working from what's called a fully populated repository. That is that each developer has a complete copy of all the source for the application. In the IBM I world, people don't typically work that way. Typically, in your development environment, you just have the things you're working on, and when you're done, you promote those forward and you clear out the stuff from development. So we have actually put in our Git support the ability to work that way. So you can say, I only want in my development repository things I'm currently working with. And so this clear out source function, which you can set the default for, says, when I do this commit, when I move this stuff forward, clear out the changes from my development library so I don't have them there anymore. So you can work in that sort of partially populated environment. I'm working the typical Git way with a fully populated repository, but you can work either way. So now I've done that Git push. I've gone ahead and pushed the code up to the shared repository. So now if I go back over here into my shared repository, I can see, oh, okay, let me go in and take a look at the history of task 1 here, and I can, oh, okay, so I have the enhancement for the webinar request and the fixed bug for webinar change, and I can go in and I can look at either one, and I can see, well, what did you do for this particular commit? Well, what were the changes that you made? So again, you have this very, very detailed history of everything that's happening, and it's all happening for you automatically. So all of that, that tracking is done for you. You don't have to do anything to make that happen. It's happening for you automatically as part of the process. So now I can say, okay, we're done with task 1. Everything's great with task 1. I want to move it now to the integration test environment where maybe I've got task 2 and task 3 and whatever. I've got all the other tasks to work on. I'm going to hit this create merge request, which says, okay, take task 1 and move it to integration. Now notice it already knows to do that. And that's because, as I talked about earlier, I've set up rules that say this is the path the code has to follow. It has to go from the task branch to the integration branch to the QA branch to production. That is the path it has to follow. So let's see, move webinar changes. Whatever. I'm going to put that stuff in here so that I know what I did, and I can create that request. And now it's going ahead and it's merging that stuff up from task 1 into integration. Now notice it checked first to say, can you do this merge? That check was to say, are there any changes in integration that aren't in task 1? Maybe task 2 changed some of the things simultaneously. It was checking and it said, no, there's no issues there. Go ahead and do it. So it's now done that merge. So if I go over here back to my repository and I look at my integration test environment, right, I now have the webinar changes here. So I've got that stuff here. It's now in my integration test environment. And same thing, if I want to move to QA, I can do the same thing. I can say, okay, we've done integration test, everything's ready. To QUA of webinar changes, whatever. So I'm going to put my comment in there. Now I'm saying, okay, move this stuff into QA. So I'm going to create that merge request to say, okay, I want to move from integration test to QA. Oh, and it says, wait a minute, you can't do that. And that's because I've set up a rule that says you can't move things into QA until you've had somebody review the code and tells you it's okay, or until you run the source scan, or until you run the automated tests. So it's not letting me move this. I need an approval. So I'm going to flip over here to my other user. So here I am in that same repository as a different user. And I, as that other user, by the way, would have gotten an email saying, hey, you've got a merge request out there. So I've now got a request out there. I can go and I can look at that request. So I can see this request that it's currently blocked. I can hit the commits button here and I can see, okay, well, here's what's in it. Here are the things that were done. And again, just like we did before, I can drill in and actually see and review the lines of code that have been changed. And I'm going to go ahead and say, okay, yeah, I looked at the code. Everything's good. Go ahead and approve that. So I'm going to go ahead and approve that merge. So now that I've done that, I think I'll go back over here to my original user and say, okay, I've gotten my approval. By the way, it tells me who approved it. And I can say, okay, go ahead and run that merge. Now, when it's doing that merge, if I go back over here to my green screen, I'm going to look at my QA library. Notice there's nothing in there right now. There's nothing in my QA library. And that's because I now have an automation set up that says, okay, when you do that pull request here in the repository to say, okay, I want to move stuff to QA, I want you to then pull the code down to, once you've done the merge, pull the code down to the IBMI, then run the build process, then run the deployment process, and put things out into my deployment library for me. So I want you to automate that whole process. And that's what you see here is there's now what's called a pipeline running, which is an automation that says, I don't want to just merge the code in the repository. I want to get it down to the IBMI. I want to run the build of the things that have changed and all the things that use the things that have changed. And then I want to actually deploy the build results to some other place. So I can actually go in and follow that process. Oh, whoops, it's already done, actually. So I can come in here, I can look at it, and I've got here now the report of that process. So I can see the entire log of exactly what it just did. So if I go down here, it'll actually show me. Down here, it says, okay, I'm going to set up the library list. So it's setting up the library list for me. And then it's going to do a git pull, says I'm going to pull down the code down to your IBMI. And then I'm going to run the build process. So it ran the build process, which was successful. It actually attaches all the compile results. So I can actually keep this as a permanent record. I can go in and see exactly what happened when I did those compiles. And then if I go down to the bottom, once it did all the compiles, it did the deployment. So it actually deployed things out. So if I go back over here to my green screen, I can do a work live now. We'll just do an F9 here, rerun that command. So if I go in now and look at my QA library, everything was built for me in the QA library. And in addition, I have this QUA1 DEP library, which is the deployment library. And if I look at that, everything is there as well. So it basically what it did is when I did the pull request, it said, okay, I need to pull down the things that have changed to the IBMI. I need to run the build based on the QA library list. I'm going to get those build results, and then I'm going to package them up and deploy them. And when I do the deployment, if there's data, if I've changed some schema of the files, it will remap the data into those files. It'll create a backup. So if you ever want to roll it back, you can do that. So it manages that and automates that whole deployment process for you. So that's kind of just a very brief step through of a standard process, right? So I went in, I made some changes. I made changes in VS Code. I made changes in PDM. I then added the changes. I then did my commit in development. I then took my development stuff and merged it into the shared repository. I then promoted it from development to test to QA. So I moved things through the life cycle, and then I had the automation that built everything for me. So that's kind of the standard thing, the standard life cycle. And I know we're running down on time here. So just a couple of things here. So notice that when I was working in task 1, But as a developer, maybe I say, you know what, I need to do some work, but I want to work in task 2. So I'm going to just say, you know what, I want to do what's called a Git switch to say, instead of working on task 1, I want to work on task 2. So I can do my Git switch. And when I do that, oops. Oh, whoops. Oh, okay. I'm working with objects. That's why it's doing that. Let's go. So if I go into work member PDM, notice I don't have those changes anymore, right? The changes that I made, I don't have them anymore because I just switched to branch task 2 where I don't have those changes. I can now make changes associated with task 2 completely independently of task 1. And all I had to do was do a Git switch. And again, if I do the Git switch back, if I go back in and say, you know what, actually I want to go back to working on task 1. And I go back in and look, now I've got the changes back, right? So again, I just changed my branch and I can be working on multiple tasks simultaneously. Multiple people can be working on different tasks. When we then move things into integration, I would get the ability to then merge those changes together. So that's just a very, very quick look at the power of being able to work in whichever environment you want. You can work in any of the environment, and we will make sure that what you are looking at reflects the current version of the code you want to be working on. So getting back to here, and just to kind of wrap things up, get back over to here. The idea is in your IBM I environment, you can work from whichever tool you want to work from, and you can still take advantage of all the power of Git. You can do the parallel development kinds of things. You can do the comparing and merging. You can run your builds automatically. You can have that be part of an automation. You can do your deploys. So you can take advantage of all the power of Git and yet still work in the environment you're used to working in. So you can continue to work the way that works for you. So basically, that I know that's a very brief, very fast overview, but those are some of the basics of being able to use Git-based DevOps tools for an IBM I environment. And with that, Maya, I think I'll turn things back over to you.
Yes, thanks, Dan. Sorry, we ran out of time today, everybody, but I will include the question and answer report as well as answers to these questions we didn't get to in my follow-up email that you'll receive tomorrow. So you can have all of that information as well as the recording. We're so excited you joined us today. Again, if you have any other follow-up questions after the fact, feel free to email me at any time, and I can get those answers for you or get you connected with Dan and Aaron for a demo or for them to get your more complicated questions answered. Again, thank you so much for joining us today. We look forward to seeing you soon, and keep an eye out for that email. Thanks, everyone. Have a good one.
Great. Thanks, everybody.